Okay, so in this problem we're going to address this question where it says show that if y is equal to cosec x, then its derivative y dash is equal to negative cosec x cot x. Now this is a straight straight out of the table that you're supplied with in your formula sheet, but it's an interesting little one to show because there are a few techniques in there that you might find quite useful in other problems. So let's start with the original statement, y is equal to cosec x. Now sometimes you might find it useful to rewrite these. So we know that cosec x is actually the same as 1 over sine of x, and that comes from our identity over here on the left. Now 1 over sine of x is actually also the same as to the power of negative 1. So we've actually got sine of x to the power of negative 1. So now we've got our original statement in a slightly different form. And the good thing about this is we can now differentiate this using the chain rule. So here we go. So y dash is going to equal 2. Now we bring the negative 1 out the front. So we've got negative, the bracket stays the same because we're using the chain rule here. Decrease the power of 1, so power by 1, so it goes to negative 2. And now we multiply by the derivative of the inner function. Now we know from our table that sine x goes to cosine x. So there's our cosine x. Okay, so let's have a look what we've got. It's, if we rewrite this first part of that, we've got a negative cosine x now, actually we'll do the whole thing, over sine squared x. Right, and moving right along, we can rewrite this as negative cosine x over sine of x times, it's a times, 1 over sine x. So you can see how we've sort of pulled the sine squared apart into two fractions there. So that's not something that's always obvious, but it's a very useful technique to have in your toolbox. And what we can say now is, well, we know from our identities that tan is equal to sine over cosine. In fact, that's up over here on the top left, sine over cosine. So therefore, cosine over sine is 1 over tan, and the invert of tan is cotangent. So that is actually cot of x, and it's a negative out the front, so I'll put that there. And 1 over sine is the same as cosec. So we have cosec x. And that actually is what we're trying to show. Because if we come back to our table, where are we? There it is at the top. Cosec, negative cosec cot. I know, they ran the wrong way, but it's still the same thing. Negative cot cosec. So just to summarize there, a few techniques are very useful. Is sometimes you might find it quite helpful to rewrite like cosec or sec or cot in this form here, where you've got one of the more common functions like sin, cos or tan to the power of negative 1. And also when you have a fraction here, something like this step right here, you may want to consider pulling part of it apart, separating part of it. So like we've done here with the sine, and the sine have been pulled into two different fractions. So anyway, that's just a quick summary of how you might differentiate a more complicated trig function.